let's see further another type of quadratic equation, or quite different sums than what we have done up till now. Again, we are going and doing method of factorization only. 4x square minus 36 equals to 0. There are some students who might be thinking as of now that there is something wrong. Up till now we used to have 3 terms. There are only 2 terms in this particular one. So is there any parameter missing? Is there something missing? No, it is not. Anybody who can recollect it and tell me what type of quadratic equation this is? Yes? Any idea? We have done this in earlier classes. We have done this. Those who fail to, once again, refresh yourself. Go to my previous videos. Did I classify that quadratic equation or further types, affected quadratic equation, pure quadratic equation? Do you remember? Or go back, learn, and then watch this video. So what type of quadratic equation is this? This is a pure quadratic equation. That's the reason I keep on saying, children, that was the only purpose for me starting refresh concept. You have to refresh your concepts every now and then. 4x square minus 36 equals to 0 is a pure quadratic equation. Now children, in order to solve these kind of pure quadratic equation, I have 2 methods, right? I shall show you both the methods, but if you ask me, sir, which one you go with, I shall go with method number 1. So I'll just jot down this as method 1, M1, method 1. 4x square minus 36 equals to 0. 4x square minus 36 equals to 0. Now in method 1, whenever we have a pure quadratic equation, we always try to convert the quadratic equation in a square minus b square, children. We try to convert in a square minus b square form. So can I say 4x square is nothing but 2x the whole square? Can I say 36 is nothing but 6 the whole square equals to 0? Can we? Indeed. Now have we converted this in a square minus b square? Where this shall be my a, this shall be my b. Now a square minus b square is nothing but a plus b, a minus b. I hope my children are aware with the formula a plus b, or rather it's 2x. So it's 2x plus 6, 2x minus 6 equals to 0. A plus b, a minus b equals to 0. 2x plus 6 equals to 0, or 2x minus 6 equals to 0. 2x is equals to minus 6, or 2x is equals to plus 6. On dividing by 2, x is minus 3, or x is 3 on dividing by 2. So if you want, you can write down the reason besides it. This is my final answer. Now what is method number 2, children? We are done with method number 1. We got the answer as xs plus 3, xs minus 3. What is method number 2? I feel after I finish off method number 2, you will find method number 2 bit easy. Somebody may find 1 also easy. I feel there are many students who will prefer method 2. I have no problem, but if you ask me, sir, what method you go with, then I will go with method number 1, and I shall tell you the reason also. It is 4x square minus 36 is 0. Again, I have written the same question. Bring this minus 36 there. Shall I say 4x square is equals to 36? Divide by 4. X square is 36 by 4. 1s are 9s are. X square is 9. Taking square root. Taking square root. Shall I say x is equals to plus or minus 3, children? This is what I wanted my students to remember if they go with method number 2. There are many who must have said xs plus 3, but children, square root of any positive integer is plus or minus 3. So I'll write down this as x is equals to 3 or x is equals to minus 3. That's the only reason I ask my children not to take method number 2. There is nothing wrong in this, but in exam, if you fail to write down plus or minus, and those who just go with plus 3 and do not write down minus 3 might lose their marks. That was the purpose I said go with method number 1. But it's up to you. Whichever method you find it easy, you can adapt it. Let me check one more sum, more or less on the same lines. In fact, it is. But the only difference you will find in this particular sum, so I want you to, have focus here also and here also. So simultaneously you can. That's the reason I have taken both the sums in tandem, side by side. So you can understand the difference. D square minus 12 is 0. Now children, you must be thinking that here this is a perfect square. Here also it has to be a perfect square. So d square is a perfect square of what? D. But here there is a catch, is what I wanted. 36 is square of 6. We don't have any number whose square is 12. So if you are thinking that this is not going to form an a square minus b square, my children, you are wrong. You can still convert it. Now how you can do so? Kindly see. Whenever we don't have any numbers which are perfect squares of it, this is what we go with. So if you want, you can take this as an important step. If you want, you can take this as an important step. Can I say d the whole square minus root 12 the whole square? Root 12 the whole square. Root 12 the whole square is nothing but 12 itself. Root 12 the whole square is nothing but 12 itself. Now have I converted in a square minus b square? Indeed. Again, this is my a, this is my b. The answer is a plus b, a minus b. So a plus b, a minus b. Now children, I would suggest you to factorize 12 and do not write down your answer over there. Now at two places is what I can factorize 12. Either I factorize my 12 here itself, or I factorize my 12 here. Choice is again yours. I prefer at any of these junctures, either here or individually, you all can factorize 12. Since I have proceeded further with my sum, I shall factorize 12 here. So d, factorize 12 as, can I say 4 into 3? Likewise, d minus 4 into 3. The same thing is what I could have done here also. Here, d plus square root of 4 is 2. We don't have any square root of 3. As it is, d minus 2 root 3. Here also, I'm so sorry, equals to 0. Here also equals to 0. So it is d plus 2 root 3 is 0, or d minus 2 root 3 is 0. So d is equals to, when this goes over there, minus 2 root 3, or d is equals to plus 2 root 3. Now those who feel that they can proceed this particular sum by method 2, as we discussed, you can minus, and again you are going to have the same answer. Right children? So this was pure quadratic equation, and we saw that how to solve sums via factorization of pure quadratic equation. Just have a glance.